Alright, so part 1 of this, show that the roots are real. Okay, for roots to be real, what does that mean? Greater than or equal to 0. Good, because they can be real and equal, or they could be real and distinct. So it's greater than or equal to 0. Okay? Now, let's figure out what's my A. The P, the thing with the x squared. My B is the thing with the x, so what's that? P plus Q. And my C is the thing on its own, Q. So I'm going to fill into B squared minus 4AC. B squared minus 4AC. Okay. Now I need to square out this again. Remember how to square out? Square the first. Product of the two multiplied by 2. And square the last. And here minus 4 by P by Q is minus 4PQ. 2PQ take 4PQ. Minus 2PQ plus Q squared. Can you notice anything about that for me, please? It's what? You've seen it at the very start of the first chapter. Square number here and a square number here. Square the first. Product of the two multiplied by 2, square the last. This is a perfect square. Yeah, exactly. It's a perfect square. So, what goes here? P goes here, and Q goes here. And what sign is it? It must be minus because that's a minus. Okay? Now, P minus Q to be squared is greater than or equal to 0. Is that true? How do you know that that is greater than or equal to 0? Because it's anything to be squared always gives you a plus. Anything squared is a plus. So this is bigger than or equal to 0. Okay? So what you can say is which is just 0. My reasoning, so I'm trying to show that they're real. If they're real, this has to be greater than or equal to 0. Greater than or equal to 0 means it needs to be 0 or a plus. Okay? This is definitely greater than or equal to 0 because it has a square on it. Now we have to do a whole other topic on this in Algebra 3. So I'm not too worried about it, but the recognizing that it's a perfect square is really important. Anything to be squared will be positive. Okay? So what we're going to say is since P minus Q to be squared is always positive, the roots are real. Okay, so this thing is greater than or equal to 0, and our reason is because it's to be squared. And if it's to be squared, it's always positive. So that means the roots are real, because I've shown this is greater than or equal to 0. Okay?
If you left out that,
no, you need the explanation. Yeah, you do.
If you have a number, like, if the 0 is a number, would you square that as well?
So we'll do more on this. It won't be a number in this case, because we're always dealing with 0 with the discriminant. So it's either equal 0, greater than 0, less than 0. Okay? So at this stage, it'll always just be 0. But if it was greater than or equal to 2, you'd bring the 2 over the inequality sign, and then you'd have a 0. Okay? But we don't have to worry about that yet.
Yeah.
Okay? We will do loads of that when we get to inequalities and things. Okay? That's Algebra 3. So that's the first part of this, show that the roots are real. They're real because this is always greater than or equal to 0. Okay? Part 2 then. Can I get rid of the board? Okay, find the roots in terms of P and Q. How do you find the roots of something? You can do the minus B formula, exactly. Okay. Okay, so minus B plus or minus the square root of B squared minus 4AC. Now, I already did that bit in there, didn't I? B squared minus 4AC. We already did it. So it's, I'm just going to replace it with, what was my answer? On the left?
Of P minus Q
To B squared. Lovely.
Listen, I'll use it divided by 2A.
Oh yeah. Thank you. Where did I get? 2A. All over 2A. So just filling into the minus B there. Using my answer from above, I've just filled that in there. Okay? What is the square root of something squared? The something, exactly. The square root of this thing to be squared, the square and the square root cancel. So what you're left with is the something, this in there. Okay, that square root and that square cancel each other. That only happens because it's all of this to be squared. Okay? If you had an extra number in there, couldn't do it.
How come the minus 4 like cancelled? Where did you get the minus?
No.
Like what happened?
This bit, we got that answer in part 1.
Yeah.
That's B squared minus 4AC.
Okay.
So instead of that, it was that. Because that was my answer in part 1. So I just replaced all of that with this. Rather than doing all this out again, like I've done already. Okay? Okay, now let's tidy up. We've got 2 answers. Okay, so the first one is when I take the plus. And the second one is when I take the minus. Okay, so the plus and the minus, I'm doing the plus up here and the minus down here. I know when I have a minus, I always put a bracket after it. Okay, because it's taking away this whole thing. I'm adding on this whole thing, but you don't need your bracket when you're adding because it doesn't affect the signs. But the minus, you do need it. So, up here, I'm going to get minus P minus Q plus P minus Q over 2P. The minus P and the plus P cancel. So I get minus Q minus 2Q over 2P. So what's that answer going to be? Minus Q over P, exactly. The 2's will cancel. Minus Q over P. And here I'm going to get minus P minus q, minus p, minus by minus plus q. And in this case, the q's will cancel. And I get minus 2p over 2p. Minus 2p over 2p is minus 1. So there's my roots. Minus q over p and minus 1. Is that alright?
Yeah.
Any questions on that?
How did you get rid of the square root in the second one?
Here?
Yeah.
What's the square root of 2 squared? What's 2 squared? 4. What's the square root of 4? 2. What's the square root of 3 squared? Square root of 9 is 3. So do you see what's happening? Square root of 2 squared is 2. Square root of 3 squared is 3. Square root of this squared is this.
Okay, but where's... Oh, the 2p was already there. Oh, I was confused where you got the 2p from above it.
Okay. Yeah. Are you okay?
Yeah.
Are you sure?
So, yeah, because that's q over p and that's p over p.
Yeah. Cancel as well. Exactly. Yeah. The cancelled. So p divided by p is 1 and minus 2 divided by 2 is minus 1. Minus 1 by 1 is just minus 1.